ఉద్యోగం చేసే వాళ్ళు ఉంచుకుని దీనికి అప్పుడే వాళ్ళు నేను అయితే 10 రూపాయలు ఇస్తాడు అప్పుడు వాడి దగ్గర ఉంటే 5 రూపాయలు తెచ్చుకుంటానండి
హలో 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 అమ్మా morning all of you hello
good morning sir yes sir
మీ మైక్రోఫోన్ అన్మ్యూట్ చేయండి మ్యూట్ లో పెట్టుకోండి హలో 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 హలో
sir చెప్పండి sir
all of you hear my voice
yes sir
okay shall you start the class
yes sir
yes sir
మొత్తం అందరూ వచ్చేటట్లేదు హలో హలో
sir yes sir
okay Amma, I would like to start the remaining session. All of you audible my voice?
yes sir
Okay
yes sir
okay so what is your total strength in class? Hello
12 13 sir
okay can I continue my class?
yes sir
So in the previous class we have to discuss about introduction to signals and systems and also different types of classification of signals. Some part of the signals are explained in the previous class. Now I would like to continue my further classifications. Now coming to the classification of signals, in that even and odd signals. The even signals are mainly represented as few types. So in that the mathematical representation of an even signal is Xe of t and the odd signal is represented as X naught of t. So the even signal expression is representing as Xe of t is equals to Xe of minus t. So similarly the odd signal X naught of t is equals to minus X naught of minus t. So this is the mathematical representation of even and odd signal. So some of the even and odd signals are graphically represented as like this. So here this is the X of t, means this is the input signal and also Xe of t. Xe of t is nothing but an even signal. So this even signal which is having some magnitude, that is about half. Here x of t magnitude is about 1. So the magnitude is nothing but amplitude of the given signal. Amplitude means voltage. So with respect to time, the signal will be varied. So here the even signal is represented as both positive side and as well as negative side. So the even signal is satisfies the condition whenever Xe of t is equals to Xe of minus t. So Xe of t is nothing but the positive signal and Xe of minus t is nothing but the negative side portion. Okay. So the magnitude of the signal is half. So the total magnitude of the x of t is 1. Similarly, x of minus t. X of minus t is nothing but the left sided portion. The magnitude of the signal is 1. With respect to time, the signal is varied. So in this case, x naught of t, that is nothing but it is a odd signal. The odd signal graphical representation is minus half and plus half. This is the reversal procedure of the odd signal. Okay. So the complete opposite sided signals are appeared both from the positive side and as well as the negative side. Now the representation of even and odd signals are satisfying the these following conditions. That is x of t equals to x of minus t and x naught of t is equals to minus x naught of minus t. So this is the simple mathematical representation of an even signal and odd signal. So these are the some of the examples which will be written like this. Now coming to the even and odd signals, which is also simultaneously represented as the following graphical representations. That is, the even signal is nothing but x of minus t equals x of t. This is for a continuous time signal. Whereas,
మణి గారు
sir,
పీపీటీ పెట్టారా మీరు?
yes sir, yes sir,
పీపీటీ అని డిస్ప్లే అవ్వట్లేదు.
display అవుతుంది sir.
ఫోల్డర్స్ కనబడుతున్నాయి అంతే.
Folders
అవ్వడం లేదు
కనిపిస్తుంది
సార్.
అమ్మ, డిస్ప్లే అవ్వట్లేదు పీపీటీ.
అంటే
అవ్వడం లేదు సార్.
ఒక్క నిమిషం, ఒక్క నిమిషం.
మళ్ళీ స్క్రీన్ షేర్ చేయండి.
చేస్తున్నాను సార్.
ఓకే ఓకే
సార్ వచ్చిందా?
వచ్చింది.
వస్తుంది సార్.
మ్యాక్సిమం చేయండి సార్, మ్యాక్సిమం చేయండి.
చేస్తున్నాను సార్. అమ్మా, అందరికి వచ్చిందా?
ఓకే ఓకే గుడ్.
వచ్చింది సార్.
ఓకే సార్, ఓకే
క్యారీ ఆన్.
ఓకే సార్. ఓకే
అమ్మా చెప్పండి, మీకు మీకు ఇందులో స్క్రీన్ షేరింగ్ అవ్వకపోతే నాకు ఒకసారి ఇన్ఫర్మేషన్ ఇవ్వండి.
ఓకే సార్.
ఓకే అమ్మ, థ్యాంక్ యూ.
అలాగే పాయింటర్ తో మౌస్ తో పాయింట్ అవుట్ చేయండి.
చేస్తున్నాను సార్. సో హియర్ the representation of even and odd signals are graphically viewed like this. The initial condition of the even signal is x of t is equals to x of minus t. So this is the condition for an even signal which will be represented as a continuous time signal. So continuous time signal is nothing but like an analog signal or a digital signal. The periodically signal will be appeared in different cycles or full complete cycles. So the same signal is represented in discrete time. In discrete time manner, x of n is equals to x of minus n. X of n is equals to x of minus n. So here x of t is the signal representation. That is nothing but the input of the signal. So x of n is nothing but a discrete time signal which will be represented as an impulse 1. So the condition of an even signal is in continuous time x of t equals to x of minus t, whereas discrete time signal x of n is equals to x of minus n. So the positive side and as well as negative side parts of the signal is appeared both the axes. So with respect to time, the signals are varied. So coming to the odd signals, the odd signal condition is minus x of t is equals to x of minus t. So this is for continuous time signals, whereas discrete time signals minus x of n is equals to x of minus n. So this is the graphical representation of this following condition. So the signal will be appeared from the complete opposite side of the signal. So this is the positive axis and this is the negative axis. So the magnitude of the signals are completely reversed, which is oppositely arrived. So this is also called as the one more example of an odd signal. Coming to exponential and sinusoidal signals. So coming to the exponential and sinusoidal signals, the mathematical representation of an exponential signal is x of
ఇంటికని
t.
చెప్తాను ఓ రోజు ఇక్కడ చెప్తున్నా రోజు ఇంటికని చెప్తాను రోజు అన్నాడే కదా
Yes sir, yes sir. X of t is equals to c into e power at. So where c is the continuous time signal, continuous time
నేను
signal,
ఆన్లైన్లో చెప్తాను కదా
where e is the exponential component, here e is the exponential component and a is the amplitude of the given signal. A is the amplitude of the given signal. With respect to time, the signal will be varied. So here x of t is
మౌస్ కలర్
represent.
మారుతున్నారు
Yes sir, yes sir. Here x of t is represented as an input signal, that is the following condition c into e power at. Okay, so from this the exponential signals which will be satisfied with the following conditions, that is the main equation is x of t is equals to c into e power at. Now bounded and unbounded signals. So bounded signal is nothing but which is graphically represented as the signal is varied with respect to time in positive side, with respect to time in positive side, whereas the signal can be uh, satisfied with the following conditions, whereas x of t is equals to uh, input signal representation, the every system is bounded and it is meaningful, a signal is always bounded. So coming to the causal condition, if the two signals are appeared both positive side, those signals are also called as a bounded condition is satisfied. Whereas an anti-causal or non-causal system, both the signals are appeared at negative side. So in this case, the graphical representation of causal and anti-causal signals which will be satisfied the two conditions, that is are bounded and unbounded signals. So one more classification and one more difference between the energy and power signals. So energy and power signals are mainly represented in signals. The energy signal is having a finite duration. The energy signal is having finite duration. So that means a signal is having completely appeared in 360 degrees, like a sinusoidal signal or a triangular signal or a square wave signal. So in this case, the signal is having a finite duration with respect to time, whereas the power signal is infinite duration. The power signal is infinite duration, and the normalized energy is finite for non-zero conditions. In this, the power signal, the normalized power is finite and non-zero positions. And similarly, normalized power averaged over infinite time is zero. So the signal condition is infinite position, therefore the normalized power is zero. So finally, the energy and power signals are mathematically represented as one simple circuit, that is, consider V of t. So V of t is nothing but one of the input signal which is having some magnitude, nothing but voltage. So that is mathematically represented as V of t. The signal is carried out with respect to time is varied, which will be voltage across a resistor R, producing the current I of t. So whenever the voltage across resistor R, some part of the current is available, that is nothing but an I of t. So the instantaneous power P of t per ohm is defined as, so the basic formula for Ohm's law, I is equals to V by R, where here we have to obtaining the power with respect to time in a given signal, which is mathematically represented as P of t is equals to V of t into I of t by R, that equals to I square of t. This is the standard notation for power signal. This is the standard notation for power signal. So therefore, the total energy of a given signal, capital E, is equals to integral minus infinity to infinity I square of t into dt. This is the total energy of a given signal, which is mathematically written as like this. Whereas average power is capital P is equals to limit t tends to infinity 1 over t integral minus t by 2 to t minus whereas positive t by 2 I square of t into dt. So why should you considering the integral position? Here the energy signal is minus infinity to infinity, whereas in a power signal minus t by 2 to t by 2. So this is the units of the given signal. So which will be considering the magnitude of the given signal. So magnitudes are nothing but signal amplitudes for both peak to peak values. Now, for an arbitrary continuous time signal x of t, so an arbitrary continuous time signal x of t is nothing but a complete sinusoidal signal or a square wave. The normalized energy E of x of t is defined as capital E is equals to integral minus infinity to infinity magnitude of x of t whole square into dt. So this is the final normalized energy of signal. So E is equals to integral minus infinity to infinity magnitude of x of t whole square into dt. So the normalized average power, which is also obtained by considering this formula, that is capital P is equals to limit t tends to infinity 1 over t integral minus t by 2 to t by 2 magnitude of x of t whole square into dt. Here x of t is the input signal. So whatever the signal we have to driven to the circuit, so that kind of signal is processed and also obtaining the power and as well as energies. So by considering these two equations, we have to obtaining the total energy and as well as the total normalized average power is find out. Similarly, in the previous, we have to explain about the continuous time signals, both energy and power signals. Now coming to the discrete time signal. So discrete time signal is nothing but it is the one of the impulse signal. So a discrete time signal is mathematically represented as x of n. So the normalized energy E x of n is defined as here x of n means x of n is the an input signal in discrete time domain, whereas the energy signal capital E in a discrete time signal summation n equals to minus infinity to infinity magnitude of x of n whole square. So in discrete time signal we have to introducing a summation. So this is the input sequence. So here small n is the number of input sequences. Small n is the number of input sequences. So where n is equals to 0, 1, 2, 3, 4 and so on. So we have to declaring the magnitude of the each and every sample. Okay. Whereas the normalized average power P of x of n is defined as capital P is equals to limit n tends to infinity 1 over 2n plus 1 into summation n equals to minus n to plus n magnitude of x of n whole square. So here the signal is appeared both the opposite versions of the graph, that is x of n is equals to x of minus n. So that is the condition for a power signal. So here the power signals are appeared both the axes of the given signals. So here the same amount of input signals are driven to the circuit. We need to obtaining the total power and as well as the total energies. So these two equations are applicable for discrete time signals, only for discrete time signals. So some part of the important points for energy and power signals. A signal with finite energy has zero power, so it is a energy signal. Energy signal is mainly contains which is a finite energy and zero power, whereas the power signal, a signal with finite power has finite energy. So if a signal is a power signal, we have to justifying the signal power is finite and as well as infinite energy, so that the signal is also called as a power signal. And a signal cannot both be an energy signal and a power signal. Okay, sometimes this point is applicable. There are signals that are neither energy nor power signals. So some part of the signals are sometimes energy signal and sometimes a power signals. So which will be obtained by explaining in problems. So a periodic signal is a power signal if its energy content period is finite, and then the average power of the signal need only calculated over complete time period. So whatever the signal we have to obtaining, either it is a power signal or an energy signal, so which is mainly considering the total cycle, the total time period of the signal is appeared in a axis or with respect to time it is applicable. So not all periodic signals are power signals, so all the periodic signals are not power signals. So it is the one of the important point. Now coming to systems. So here in previously we have to explain about different types of signals. Now coming to systems. So what is meant by system? So system is the one of the important parameter, so which will process the input signals and it can produces an output signals. So we have to driven any kind of input signal to the system. The system can function the input signal and it can provide the corresponding output signals are available at output side. So for example, systems examples are considering an amplifier. In amplifier circuit, we have to driven one input signal, that is like 20 millivolts input signal is driven to the system or nothing but an amplifier. So that 20 millivolts input signal is amplified and it is boosted into the magnitude of the signal is increased at output side. For example, the 20 millivolts input signal is applied to the amplifier. The amplifier can amplifying the input signal up to 1 volt. So the input signal in magnitude is increased. So what kind of function is inbuilt here in a given system? So we are considering an amplifier. The amplifier can function the input signal. So therefore the system which will make inbuilding any kind of circuit or any kind of component, they have to providing some certain output signals. Hello, అమ్మ మ్యూట్ లో పెట్టుకోండి మీ వాయిస్ మౌత్ మైక్రోఫోను. Students, hello,
అదే వాటర్
hello.
ఏదో చాప్టర్.
Now, it is the simple definition of a system. Systems process input signals to produce and output signals. So the better example is an amplifier circuit. So the examples of a system, a circuit involving a capacitor can be viewed as system that transforms the source voltage, that is nothing but signal, to the voltage signal across the capacitor. So which is nothing but one of the simple circuit. Whereas a CD player takes the signal on the CD and that transforms into a signal sent to the loudspeaker. So what you have to observe, a CD player can take the signal on the CD and transforms into a signal sent to the loudspeaker. So the signal will be loudly available at output side. So loudspeaker is nothing but an output device. The input device is a CD player. So they have to providing a large amount of voice signals are available by considering one other example. Whereas a communication system is generally composed of three subsystems. So the communication systems are mainly contained three systems, that is transmitter, channel and receiver. So the transmitter is the one of the important terminal unit, and as the receiver is the one of the important receiving unit. In between we need to use a channel. So channel is nothing but they have to providing some optical fiber wires and as well as coaxial lines which will be used in between the transmitter and receiver circuits. So the channel is typically attenuates and adds noise to the transmitted signal which must be processed by the receiver. So this is the communication system. In this, the practical view, they have to adding some noise signals because of there is a channel is available here in between the transmitter and receiver. So here the channel is nothing but an optical cables and as well as the coaxial lines. If the optical cables are does not propagating the signals in proper manner, so there will be some noise will be there which is added to the current signal. So there is some noise will be added into the given signal. So these are the some part of examples of a system. So here how is a system is represented. So the system is graphically represented as like this. So it is a system. The input of the signal, the input of the system is represented as x of t, whereas the output of the system is y of t. So here input signal is nothing but the input signal is represented as x of t, output signal is represented as y of t. So simply and mathematically represented as these two signals. So here x of t is driven to the system. The system is processing the signal x of t. The system is processing the signal x of t and they have to providing the output signal y of t. So it is the simple graphical representation of a system. So the system can be represented as the ratio of the output signal over the input signal. So this is the ratio, the output function of the system, that is h of t is equals to ratio of y of t by x of t. So they have to processing the input and output functions. So the system by the input signal we getting the output signal. So we have to multiplying that means h of t is equals to y of t into x of t. So this concept is very important in a given systems. Now coming to classification of systems. Here the classification of systems, there are several types. That is first one is causal and non-causal, linear and non-linear, time variant and time invariant, stable and unstable systems, static and dynamic systems. Now coming to the causal systems. So causal system is nothing but if a system is said to be causal, if the present value of the output signal depends only on the present and past values. So if the system is a causal system, ఒక system ని మనం causal అని ఎలా చెప్తున్నాం అంటే the system is mainly depending on both present and past values, both present and past values of the given input signals. అంటే causal system అనేది మనకు దేని మీద డిపెండ్ అయి ఉంటుందంటే present and past values మీద డిపెండ్ అయి ఉంటుంది. So the example of the causal systems are in discrete time y of n is equals to x of n plus 1 by 2 into x of n minus 1. So here y of n is the discrete time signal output function. This is the system output function, whereas x of n is the input sequence. This is the input sequence. So here we are observing given system. This is the x of t, this is the y of t. So the signals are represented in time domain. The signals are represented in time domain, whereas the signals are represented in discrete time signal. Discrete time signal, whereas y of n is equals to x of n is the present value, n minus 1, this is the past values. Okay, so here the causal system is mainly depending on present and past values. So it is the one of the best example for the mathematical expression y of n equals to x of n plus 1 by 2x into n minus 1. So this is the present value, this is the past values. So therefore the following equation is satisfying the condition of a causal system. Now non-causal systems. A system is said to be non-causal or anti-causal if the present value of the output signal depends only on the future values of the input signal. So future value is nothing but n plus 1. These are the future values, n plus 1. Here x of n or x of n minus 1. So x of n is nothing but present value, x of n minus 1 is nothing but past values. Here we are observing n plus 1 is nothing but future value. So a system is completely depending on the future values. That kind of system is also called as a non-causal systems. It is the graphical, it is the mathematical example of a given non-causal system. Y of n is equals to x of n plus 1 plus 1 by 2x into n plus 1. So it is the mathematical representation of a non-causal system. Now coming to linear and non-linear systems. Hello all of you. Hello. Hello.
Hello, sir.
Kindly open your unmute your speaker.
Okay, sir.
Today class, today I would like to explain about some signals and as well as systems functions. All of you able to understand?
Okay, sir.
All of you able to understand?
Yes, sir.
My audio is audible now.
Oh, yes, sir.
Okay. So
Sir, audible, sir.
okay. Today I am completing the signals portion. I am also entering into the systems portion. Okay. If any doubts in signals and as well as systems. Hello.
No, no.
Are you able to understand?
Yes, sir.
Okay. If any doubts are there, kindly ask the doubts regarding signals and as well as systems. Okay. Hello.
Okay, sir. Yes, sir.
Okay. So coming to the linear and non-linear systems. So here linear system is nothing but the linear system if it is satisfy the principle of the superposition theory. For checking the linearity of the system, firstly we have to check the response due to the linear combination of inputs. So in a superposition theory, we need to given multiple inputs of the signals in a given circuit. Okay, now we have to find out the responses of the given circuit which is satisfying the condition of the superposition theorem. Okay, so we have to combining the two outputs linearly in the same manner. The inputs are combined and again the total response is checked. So here we are observing two inputs are given to the circuit. We need to combine the given inputs. Finally, we have to obtain the total response. Okay, if the response in second step and third steps are same, the system is linear. Otherwise, it is a non-linear system. So now coming to time invariant and time variant systems. So time invariant and time variant systems. So a system is said to be time invariant if a time delay or time advance of the input signal leads to a identical time shift in the output signal. So the time invariant system is mainly mathematically represented as yi of t is equals to h of x of t minus t naught. Here t minus t naught is nothing but a delayed signal. T minus t naught is nothing but a delayed signal where capital H is the transfer function. Where capital H is the transfer function. So yi of t is nothing but the instantaneous signal of the output response with respect to time, which is represented. So yi of t is equals to h of x of t minus t naught. So this is nothing but a delayed signal or a time advance of the input signals. So and this function h of x of t minus t naught is about h of s t naught into x of t, that equals to hs t naught x of t. Okay, so the hs means this is the transfer function representation in a given time delayed signal. The this function is simply represented as y naught of t is equals to s t naught y of